Hey, welcome back, ladies and gentlemen. So let's start creating a simple graph here. Now, we need to learn the concepts behind a graph before we actually add any data there. Now, it may look complicated, but graphs are actually easy to make using SVG. Okay. So we just need to make a simple graph here, but let's look at the basics of SVG first before we can do any of that. So let's get started. Now, if we go to our views section here, the admin and the sales section, of course, there's an if statement here where we have the graph view. So our graph will be created down here. So to begin, we create an SVG. Now, SVG stands for Scalar Vector Graphics. Okay. So, in other words, an SVG is a vector graphic. So what this means is that, you see, there are two types of images on a computer. The first one is pixel-based and the other one is vector-based. So you may be wondering, what is the difference? Now, the difference is that normally, let's look at, if I can find an image here, let's look at this one right there. In order for this image to exist, what's going on is there are pixels from left to right. So there are small dots here that represent colors. Okay. Each dot can give you red, green, or blue. And then the combination of both creates the other colors. So in a place like this, the pixel is white. On this one, a pixel is black. But the bottom line is that there are pixels this way and there are pixels this way. So if you zoom in this image rather greatly, you'll reach a point. Unfortunately, I can't zoom here. Let me try and open containing folder. Let's see if we can do an insanely highly detailed zoom. Unfortunately, it doesn't go that far, but eventually you start seeing these jaggedy lines like this because you get to a point where you see individual pixels on this image. And that is the problem with vector graphics, because they have a limit. You can zoom into a point where they stop making sense. But vector graphics are different because they do not use pixels. They use vectors instead. So let's see here. Let me try to explain how a vector differs from a pixel. So for normal normal images, sorry, if you zoom in deep enough, let's try and open this with, let's click edit. So you see, if I zoom in enough, as you can see here, I've already started seeing the pixels. So this is a pixel-based system. So at some point, you start seeing individual pixels. Like here, there's one pixel. So there are actually 4 pixels here. 1, 2, 3, 4 on one click. Okay, and the combination of that color, of the colors there, determine what the image looks like. But if you have vector graphics, what happens is this. Let's say you want to draw a line like this one, right? Okay, let's use, wow, I can't even draw a straight line anymore. This is insane. Let me click line. Excuse me there. Okay, there we go. So keep in mind, this is a pixel-based image. That's why you see these jagged edges like this. But if this were a vector-based graphic, what will happen is this. The image has coordinates here. There's X and Y, okay? Just like it is with pixels. But the difference is you're going to put, instead of putting the pixels that represent this image, you're going to put an equation instead and say X and Y. So you tell it that there's an X, let's come back to the brush. There's an X and Y coordinate here, right? This right here. You tell it X, Y. You say, let's say this is 2, 2, right? 2, I don't know, 2 pixels or something, I don't know, plus 2 pixels in the Y. So you're going to have two, oopsie, this is wrong actually. You're going to have 2 here. Let's say this is a unit of 2y because y is up and down and x is left to right. So 2x here. So you're just telling it that the line, first of all, you tell it that this is a line. So you're going to mention that I'm creating a line, okay? And then the line, because now it knows that it's a line, it only needs 2 sets of coordinates, where the line starts and where the line ends. This is all the information you need to represent a line. You just need to know that first of all, it's a line, that's number 1. And second of all, the line starts from here and ends there. That's it. So you say line starts at 2x, comma, 2y, and then it ends here at maybe 10x, 10y, and then 10x. So that's all you tell it. A line from this to 10x. Oh, my writing skills with the mouse are terrible. Comma 10y. So with this information only, you can create a line. However, there's a problem. You need to know the thickness of the line. How thick is it? Okay. So then you can add a thickness now. Okay. Thickness. And then you say, okay, what color should the line be? Then now you add a color to the line. So this is the information you need in order to represent one line. Now, if it's a circle, you start getting into other issues. But each graphic has a way to be represented: a line, a circle, a square, etc., etc. So you can see that it makes the fact that this is just a line, it's not pixels, it's just an equation or information that tells us something about the line. It means the line is redrawn every time you refresh the page. So for example, if I have this line and then I zoom in and it's a vector graphic, I zoom in quite a bit up to this point, you will still not see any jagged edges because the equation is just redrawn again. So it's just say, okay, what coordinate are we right now? We are here. So now I'm just going to redraw a line from here to there. So the fact that the line is refreshed every time means it's always full quality, because it's not really pixels. It's just, you're just giving instructions to the computer on how to draw the line itself. So the computer does the drawing instead of using pixels. This means that at every resolution, the image just needs to be redrawn again, and then it's refreshed, which means it always looks crystal clear. That's something you can't do with pixels, because no matter what, the pixels are just enlarged and eventually you will see where the seams are. Okay, so for circles, you just need to know the center point of a circle. So let's say this is a circle. You just need to know what's the center of the circle and what's the radius. That's it. So let's say this point right here is 10 y and then 10x, right? So those are the coordinates for the center of the circle. And then if you know the radius of the circle, let's say the radius is 5 units, that's all you need, because then you just maintain 5 units around this point, which will give you a circle. So that's all you need: the radius, the center of this, and then now you have to think about the fill color. Do you fill this circle with a color? And then does the circle have an outline as well? And what color is the fill? What color is the outline? Etc. So the same thing goes for a square. Now a square like this one, if you know it's a square, you know all the lengths are equal. So all you need is this xy here. What coordinate is this corner? And then what unit is the x? And that's it. Then you can use that same unit for the y, and then just join them where they meet. Then you have a square. If you want a rectangle that's irregular, might be longer this way than it is this way, all you need is the xy coordinate of this one, and then the xy coordinate of this part. So the xy here, xy there, and then just join the two lines and you have your square. So as you can see, this is how vector graphics work. So it's just an issue of creating squares, rectangles, lines, how thick are they, just like that. So it's pretty easy stuff. So let's get into it and see exactly what you need. Now, wow, my throat is itchy. Now, in order to be able to do this, you need a proper coordinate system. As you saw, we needed X to know exactly where we are on the X and exactly where we are on the Y. Now, you can use percentages, but it has to be a percent of something. We need to have the coordinates of the image. Let's say, what I mean is we need to have a resolution of that image. So let's say we create an image that's a 100 width by 100 height, right? So at least we know that when we are saying 50 pixels, we mean here, halfway, and 50 pixels we mean there. So that's good. But then, so this right here is known as the view box in SVG. It's the view box, the actual resolution of the image, where you can use actual pixel counts to coordinate your system. And then you can later enlarge or reduce the image, just like normal images. You know, you can have a photo that is 400 by 400 pixels, but when displaying it on your website, you can display it at 1000 by 1000. That's entirely up to you. So you can do the same with SVG. You can create a view box, but then you can scale it in terms of width and height. Okay, so let's try something here before I bore you to death with all this theory.